So when we're adding and subtracting two rational expressions with different denominators, we're going to have to use that concept of a least common denominator. Basically what we're going to end up doing is we're going to rewrite each of these rational expressions as an equivalent rational expression with the same, the two will have the same denominator. Same idea as we did in fractions. Here, let's take a look with, remember in fractions, for instance, if we had 1/28 and 5/6 that you wanted to combine, either add or subtract, doesn't really matter. Okay, the way we did that is we have to figure out what is the least common denominator between 28 and 6. Now before I jump into this, why do I say the least common denominator? Wouldn't any common denominator work? Well, yeah, that would. It turns out that we use the least common denominator because that involves the least amount of work for us to do. If we use just a regular common denominator, the numbers could get big, they could get confusing, they could get hard to cancel out at the end, at the end of the problem. So it's usually better to find that least common denominator up front, and that makes your downstream work a little bit easier. Now here's how you do it. I'm going to take the 28 and I'm going to take the 6. And what I'm going to do is I'm going to do the prime factorization of 28. 2 times 2 is 4 times 7 is 28. Notice that these are all prime numbers, and I've put them in order just so it makes it easier for me to take a look at things. Now there's a way that I can do that. In an earlier example I showed you how to develop the prime factorization of a number. So this is the end result of that. Now 6, prime factorization of 6 is 2 and 3. And what you look at is you say, well, what are the different factors between these two numbers? Well, I see a 2, I see a 3, and I see a 7. Okay. And what I end up doing is take a look at each one of those factors, the 2's first, and what I do is I take the most occurrence of those. In other words, there's 2 2's here, there's only 1 2 here, I'm going to take 2 of them over here. And then I'll work on the 3, well, this is the only one in there, so I'm going to take that one. And then similarly the 7 I'm going to take. So in order to find that least common denominator, I'm going to take my LCD, in this particular case, is going to be that 2 times the 2 times the 3 times the 7. And that all ends up being 82. Okay, so you see how I did that? I found prime factors of each one of the denominators. I identified the prime factors, and I took, for each prime factor, I took the most number of time that it occurred. Okay, then I multiplied all those together, and that turns out to be my least common denominator. All right, now let's go back to our original problem over here. Now remember what I did is I took a look at each one of the denominators, and I factored out each one of the denominators. So for instance, y squared plus 2y minus 3, if you factor that out, you get y plus 3 and y minus 1. The other denominator, y squared minus 3y plus 2. Again, if I factor that out, I get y minus 2 and y minus 1. All right, so now let's take a look. What are all the different factors that I have here? Now, it turns out that y plus 3 here is unique, so that's one of them. It turns out that y minus 2 occurs once over here. And then y minus 1 is common to both of them. So I'm just like I did with the 2's and the 3's before, I'm just going to take the most number of occurrences, which is 1. And I've circled my 3 factors that are going to comprise the least common denominator in this particular case. Y plus 3, y minus 1, y minus 2 is equal to my least common denominator. So we're going to be using this technique when we combine fractions, that is when we add or subtract fractions that don't have the same common denominator.